Hello guys, we are from Group C and we gonna talk about the rotary engine and how it works. So let's jump into the video.
I'm Patrick and I will introduce you the history of rotary engine and also the introduction of it. The rotary engine is a type of internal combustion engine, usually designed with an odd number of cylinders per row in a rotation manner. The crankshaft of the engine remains stationary when in operation, with the whole crankcase and its attached cylinders rotating around it. The engine is a very efficient solution to the problems of power output, weight, and reliability. The rotary engine has cylinders arranged radially around a central crankshaft, and crankshaft remains stationary with the whole cylinder block rotating around it. In the rotary engine, we have monosoupape rotaries and also normal rotaries. For monosoupape rotaries, it had no throttle and hence power could be only reduced by intermittently cutting the ignition using a blip switch. It took most of the air into the cylinder through the exhaust valve remained open for a portion of downstroke of the piston. Normal rotaries, we had normal inlet valve that has the fuel was taken into the cylinder and already mixed with air. As we know, as in normal 4-stroke engine, with the ability to keep the fuel or air ratio constant over a range of throttle openings, it was precluded by the spinning crankcase. History of genome engine. It is the work of 3 engineers of Swingrim brothers, Louis, Laurent, and Augustin. The brothers' first experimental engine is said to be 5-cylinder model that developed producing 34 horsepower. Swingrim brothers then turned the rotary engines in the interest of better cooling, and the first production of rotary engine, the 7-cylinder air-cooled 50 horsepower 37 kilo. Swingrim brothers introduced the new monosoupape, which is single valve series, and replaced the inlet valve in the piston by using a single valve in each cylinder head, which doubled as inlet and exhaust. In the early days, the genome engine was used in warplanes in World War I and World War II. Kind of interesting, isn't it?
Hello everyone, my name is Wan Amir bin Wan Azmi and I will explain the theoretical background of rotary engine. Okay, now I will explain how rotary engine works. Basically, a rotary engine follows a 4-stroke cycle. The first stroke is intake stroke, and that's where the intake valve is open and the fuel and air mixture go inside, and moving piston sucks the fuel and air mixture. Then the piston begins to move up and it compresses the air and fuel mixture in the compression stroke right before the piston hits the top. After that, spark plug fire and those sparks start burning the fuel air mixture, causing the gases to explode and forcing the piston back down in the power stroke. As you can see, the piston is going back down, and then the crankshaft starts spinning the piston back up to the top, forcing out the excess burnt fuel air mixture in the exhaust stroke. Next, I will tell you the parts of the rotary engine. The first part is crankshaft. It's able to convert the reciprocating motion to rotational motion. And next is connecting rod. It transfers motion from a piston to crankshaft, which acts as a lever arm. Next is piston. Transfer the expanding force of gases to mechanical rotation of crankshaft via a connecting rod. And then inlet and outlet valve, it allows to enter fresh air with fuel and to exit the spent air fuel mixture from the cylinder. Last but not least is spark plug. A spark plug delivers electric current to the combustion chamber, which ignites the air fuel mixture, leading to abrupt expansion.
Hi, my name is Zatira and I will explain about development of rotary aero engine. So let's go. The power unit used in the early aircraft at the beginning of the XX century was rightly derived from water-cooled automobile engine or air-cooled motorcycle engine. The water-cooled type were penalized by their heavy weight, while the air-cooled were prone to suffer for overheating. The rotary engine was one of solution experiment with success at the beginning of XX century, a period where we reached in innovation and scientific progress. Before its aeronautic application, the rotary principle was already known. It was used in various applications such as millet motorcycle in 1888. The Millet motorcycle, designed by Felix Theodore Millet, may have been the first motorcycle to use pneumatic tires. It had an unusual radical configuration rotary engine incorporated into the rear wheel, believed to be the first one ever used to power a person-carrying vehicle of any type. They produced their first model, the now 50 HP Omega, in 1908. This engine is usually considered as the model of aeronautical rotaries. It was adopted by many pioneer aviators and widely used to set records of endurance, speed, and height. The Society Desmoster norm of the Sagan brothers was the first and the most important rotary aero engine manufacturer of the early rotary era. Their engines were also produced under license in many countries. Other manufacturers like Leroy, Segrap, Benteler, Oberrussell, and Simon Husker started to design and produce a large number of models and variants. Rotaries were broadly used until the end of the First World War. Their success and technical development were as quick as their decline. The Segan brothers introduced a new design of rotary, the monocephaled, in which the inlet automatic valve of the piston crown was limited. This type of engine has a single overhead trigger valve with an unusual timing that is used both to draw fresh air into cylinder and to discharge the exhausted gases. The latest evolution of rotary engine was the counter-rotary type, first and only designed in 1914 by Simon Husker. The distinctive feature of this type of engine was the crankcase rotated in one direction while the crankshaft rotated in opposite one.
Hello, my name is Walford Connell and now we're gonna talk about the current application of rotary engine. Douglas C-47 Skytrain was last used in the Vietnam War between 1955 to 1975. These aircraft are using Pratt & Whitney R1830 twin MUPS engine at its power plant that can produce power up to 1200. After the war ended, the United States Air Force has been using this aircraft until the year of 2008, and these aircraft also have been used as a civilian airline in the year of 2012. Swordfish LS-330-26, an aircraft that is built in the year of 1943 by Blackburn Aircraft. These aircraft are using Bristol Pegasus 3M engine that can produce power up to 619 horsepower. For now, this aircraft is undergoing an engine rebuild and piston check because of an old technology used in this aircraft. Hawker Sea Fury, an aircraft that used in World War II. This aircraft is designed in September 1942 by Sidney Camp and uses a Bristol Centaurus 18 and can produce power up to 2,480. The first car that is built in the year of 1898 used 3 rotary engine and named as Model No. 1 by the Adams Farrell Company. There are several more cars that the company built, but until the year of 1912, and the only model that managed to be saved is the Series 6 455 HP touring car which used 5 rotary engines. For now, there is no more car that being made by any company that using rotary engine because of the lack of efficiency of the engine. The Millet motorcycle, which is made in the year of 1892, is the first motorcycle that is built where the rotary engine is mounted at the rear wheel of the motorcycle. Megola, the front-mounted rotary engine, managed to win any races in the year of its production, and this motorcycle is built by Fritz Cockrell in the year of 1920. This is the only motorcycle that been mounted by rotary engine in the mid-80s. For now, there is still no motorcycle that use rotary engine besides of Wankel rotary engine. But who knows that someday in the future rotary engine may be used again to power a motorcycle and automobile.
My name is Sabrina and I'm going to talk about limitation and advantages of rotary engine. Rotary engine is widely used during World War I and years immediately preceding that conflict in 1914 to 1918 as an alternative to conventional inline engines. There are 3 main factors or advantages contributed to its success during those years. First is its smooth running. A rotary engine delivered power very smoothly because there are no reciprocating parts and the relatively large rotating mass of the crankcase or cylinders acted as a flywheel. Next, rotary engine can improve cooling. When the engine was running, the rotating crankcase or cylinder assembly created its own fast-moving cooling airflow, even with the aircraft at rest. The third factor is weight advantage. Unlike other conventional engine, rotary engine does not need flywheel added to smooth out power impulse and reduce vibration. Thus, they gain power to weight advantage by having no flywheel. Why rotary engine is no longer popular? This is due to the limitation of the rotary engine. First, it is due to inefficient total loss burning system. The centrifugal force of the revolving crankcase was directly opposed to any recirculation during the lubrication of the whole engine. Thus, next is due to its virtuality. Rotary engine require frequent maintenance to avoid tried and damaged engine as it excessively consuming a lot of fuels or oil. Next, the engine control were tricky. This produced stability and control problems in aircraft in which these engines were installed, especially for inexperienced pilots. Lastly, rotary engine excessively emitted hydrocarbons and carbon dioxide produced from the combustion of motor oils above average fuel consumption, which is not great for the earth.